Hello. Um, Good morning. We made it. Coffee. Um, yes. Okay. Am I late? How late am I? All right. I'm all right. Yes, actually, I think it is 10 minutes later. That's pretty good. Yes. I had a hard time just getting ready, but I guess I made it. All right. Should we just start so that I can be done at a normal time so that I don't finish in a hurry? I might be able to stream for an hour and a half. We'll see. Oh, yesterday, even though I had the program sorta running, I just watched it. I don't know, collab. I guess I paused it myself. Yeah, no, I paused it myself. I didn't continue it, so I don't really know if it worked or not. Yeah, I had other things to do, so maybe I can, I don't know, run it again, but I don't think I will optimize it. Maybe I can run it with the GPU inside Colab. I don't know. Like, that's as far as my efforts might go for that program. And we are still in the chapter 5, the Hugging Face dataset library. Now we will be going over how to deal with bigger databases. And then on the CMU side, yeah, we are still talking about the parts of transformers. Okay, I think I'm sort of brought to, updated myself, just bring myself. For the background noise, I like what currently is happening, but I also want to change it, so it's currently wind, cricket, and birds. I feel like waves and rain and thunder, which I think was actually this mix. Let's see. Yep, it was this mix. Fire? No fire. Was it this mix? Oh, okay, so this is the wind and thing. I'm gonna delete the mixes so that I don't confuse myself. Thunder. I don't feel birds. Okay, so we have thunder. Maybe waves? Should I just... Oh, what? Wait, rain is on? No, but it's thunder. Wow. Okay. Yeah, that sounds nice. Well, apparently there was actual rain last night, but I didn't see it happen or felt it. I just heard the wind. Okay, so, oh, I really like the sound. Big data to the rescue. Yes, Hugging Face datasets to the rescue. Nowadays, it is not uncommon to find yourself working with multi-gigabytes datasets, especially if you're planning to pre-train a transformer like BERT or GPT-2 from scratch. In these cases, even loading the data can be a challenge. For example, the web text corpus used to pre-train GPT-2. Is it web text? Huh. Of over 8 million. Wow, consists of over 8 million documents. And is the background noise loud? I can make it not loud, or I prefer if it was loud, but I don't want it to be too loud. Just want it to be background noise. It's like real thunder, almost. Okay. I can make the voice higher for myself. So consists of 8 million documents and 40 gigabytes of text. Wow. Wow, that's a lot. Loading this into your laptop RAM is likely to give it a heart attack. Haha, laptops don't have hearts. Unfortunately. What? Fortunately, brain. This is fortunately. HuggingFace datasets has been designed to overcome these limitations. It frees you from memory management problems by treating datasets as memory mapped files, and from hard drive limits by streaming the entries of the corpus. Okay, so let's learn how to stream a dataset, not how to stream on Twitch. That I think we're past that. Okay. The whoosh is still loud.
Memory mapping and streaming. In this video, we'll take a look at two core features of the datasets library that allow you to load and process huge datasets without blowing up your laptop CPU. Nowadays, it's not uncommon to find yourself working with multi-gigabyte sized datasets, especially if you're planning to pre-train a transformer like BERT or GPT-2 from scratch. In these cases, even loading the data can be a challenge. For example, the C4 corpus used to pre-train T5 consists of over 2 terabytes of data. To handle these large datasets, the datasets library is built on two core features, the Apache Arrow format and a streaming API. Arrow is designed for high-performance data processing and represents each table-like dataset with a column-based format. As you can see in this example, column-based formats group the elements of a table in consecutive blocks of RAM, and this unlocks fast access and processing. Arrow is great at processing data at any scale, but some datasets are so large that you can't even fit them on your hard disk. So for these cases, the datasets library provides a streaming API that allows you to progressively download the raw data one element at a time. The result is a special object called an iterable dataset that we'll see in more detail soon. Let's start by looking at why Arrow is so powerful. The first feature is that it treats every dataset as a memory mapped file. Now, memory mapping is a mechanism that maps a portion of a file or an entire file on disk to a chunk of virtual memory. This allows applications to access segments of an extremely large file without having to read the whole file into memory first. Another cool feature of Arrow's memory mapping capabilities is that it allows multiple processors to work with the same large dataset without moving it or copying it in any way. This zero copy feature of Arrow makes it extremely fast for iterating over a dataset. In this example, you can see that we iterate over 15 million rows in about a minute just using a standard laptop. That's not too bad at all. Let's now take a look at how we can stream a large dataset. The only change you need to make is to set the stream equals true argument in the load dataset function.
Okay.
This will return a special iterable dataset object, which is a bit different to the dataset objects we've seen in other videos.
Oh, hi.
This object is an iterable, which means we can't index it.
Alaikum assalam wa rahmatullahi wa barakatuh. How are you doing? The other day I was talking to you on Twitter. Yeah. I hope you're having a lovely day today.
To access elements, but instead we iterate on it using the iter and next methods. This will download and access a single example from the dataset, which means you can progressively iterate through a huge dataset without having to download it first. Tokenizing text with the map method also works in a similar way. We first stream the dataset and then apply the map method with the tokenizer. To get the first tokenized example, we apply iter and next. The main difference with an iterable dataset is that instead of using a select method to return examples, we use the take and skip methods because we can't index into the dataset. The take method returns the first n examples in the dataset, while skip, as you can imagine, skips the first n and returns the rest.
Okay.
You can see examples of both of these methods in action, where we create a validation set from the first 1000 examples and then skip those to create the training set.
Right. That's basically SQL. Alright. Alhamdulillah. Good. What about me? I'm pretty good. Just feeling busy in the head because there are things that I need to get done that I wasn't able to get done yesterday, and yeah. Otherwise, great. Alhamdulillah. Busy is good most of the time. And I have a task that I still haven't figured out how to fully tackle it. When you work on something new and you don't really know what will happen, and that uncertainty I don't like it, obviously, but I know given time I will be able to tackle it. I've done other things before. So yeah. I'm currently in the uncertainty that I don't like, but inshallah, it will be good. So working with big data, a lot of data. In this section, we will explore these features of the HuggingFace dataset with a huge 825 gigabyte corpus known as the pile. What's the pile? It's an English text corpus that was created by Luther? That's a company name? That's weird. Where are they from? Why does it sound with L? Maybe Spanish? Pretty cool. The answer is no. I took a year off of work. I am not an employer right now. I have no job right now. Technically, I still I still have the title of being an employee of a place, but I'm not working there. Taking the year off, and yeah, working on a personal project that doesn't really pay, but I'm alhamdulillah good financially, so I guess I prepared myself for the year off. For training large-scale language models, it includes a diverse range of data sets spanning scientific articles, GitHub code repositories, and filtered web text. The training corpus is available in 14 gigabyte chunks. That's pretty good, actually, when databases are not filtered, but there are databases that are one thing given, that's all we have, and then another that you can use smaller version, bigger version, mid-sized version. You can download several of the individual components. Let's start by taking a look at the PubMed abstracts dataset, which is a corpus of abstracts from 15 million biomedical publications on PubMed. It's basically archive for biomedical publications. The dataset is in JSON lines format and is compressed by using the Z-standard library. I don't know what that is. So we need to install that. The Z-standard? Okay. I'm gonna duplicate the collab and go with it instead of writing it myself. Thank you. Yes. Brave, selfish, maybe a bit crazy, all of that. Yeah. Thank you. Next, we can load the dataset using the method for remote files we learned in section 2. Just give it the URL, basically. Load dataset, and then give it the URL. By the way, the background noise is fake. If you can't tell. It's just background noise instead of music. Alright, so this is our link. This is it's JSON, and we are taking the split one. But if we just load it, wouldn't that take like a lot of time? We can see, should I load it or should I cancel it? Try and load it and then cancel it. Oh, sorry. Copy to drive. And then we'll start. By default, HuggingFace dataset will decompress the files needed to load a dataset. If you want to preserve hard drive space, you can pass download config delete extract it to true to the download config argument of load dataset. Does that mean delete the, where are we? Builder class. Download config. Oh, whoa. What did I do? Does that mean whether to keep or delete the extracted files? Why would we delete them? So we would just... Why would we delete them? Wouldn't we want it to be decompressed? Interesting. Alright, if I try to run this, wouldn't that take like super long? Oh, error. What? It doesn't exist anymore? Uh-oh, I'm in trouble. Let's try again. Okay, not that. Maybe that? Finding a link that works. Oh, hi. Sure, reading you. Pile is no longer hosted. Uh-oh. The pile does not exist anymore. Where would we get it if not there? Download. No. See? Hosted by the I. But the I is no more. I'm not gonna download it, but I mean, if you take me there. Whoops. But who is hosting it then? It is, however, still shared among people and can be found. Public torrent. Hashes of the original can be obtained if it's requested. Though the pile was removed a good while back, this file was made due to because people search about it. Okay, there's some on Hugging Face. That's pretty good, but it's not abstract. It's news. Let's see. Big Code, the stack version 2. Oh, that's pretty. I am here, yes. Do we have the med thing? Small bit, okay. I love this for me, you know? Just everything not working. Can I try to find was it PubMed? I guess I shouldn't search here. I should search here. They're everywhere. There are some lawsuits over the book's 3 parts of the pile, I believe. Oh, wow. Because of lawsuits. That's interesting. PubMed abstracts. I doubt I can find it searching like this. Alright. Something exists. What would the size be? But these are... I'm looking for datasets, right? Not models. Did I search in models? I did search in models. Alright. PubMed. There it is. This is... What is this? PubMed comprises more than 36 million citations for biomed. Are we looking at citations? I don't want that. This is just citations. How? Okay, abstract. Good. That is what we wanted, actually. Right? We have author list, abstract, title, chemical list, and number of references. Is that what it's supposed to look like? Meta and text. That's not what it was supposed to look like. It was supposed to be text as an abstract, and then meta being ID and language. You know what? Right now I'm feeling super lazy, so I'm just going to read through this. I'm not gonna try and fix it. I tried to fix it. I'm not gonna try and fix it. Okay. So, let's look at the code, even though it won't work. We are loading it here. We're just looking at one record, and then what is PSU utilities? Okay, PS utilities. Process memory info. Oh, we're looking at how much RAM is used. That's pretty interesting. Okay. So this looks like abstract from a medical article. Now let's see how much RAM we've used to load the data set. Magic of memory mapping. Simple way to measure memory usage in Python is with PS utility library, which can be installed like this. Provides a process class that allows us to check memory usage of the current process as follows. So we can say this thing process.memory info.rss. Wow, it's RSS. And I guess we're making it megabytes and a float. and it's using 0.5 gigabyte. Here the RSS attribute refers to the resident set size. What does that mean? Which is the fraction of memory that process occupies in RAM. This measurement also includes the memory used by the Python interpreter and the libraries we've loaded, so the actual amount would be smaller, I see. For comparison, let's see how large the dataset is on, how would we know? On the disk. Okay. Using the dataset size attribute, since the result is expressed in bytes like before, it should be manually converted, I see. Resident as in not mapped out to the page file swap file. Okay. So we used this to look at RAM. Now we're saying pumped dataset size. Oh, sorry, PubMed. Okay. So this is the number of files, just giving it, and then dataset size. Are we just looking at dataset size? Like just PubMed, the thing we loaded, and then just dot size? So point is, this is how much we're using in memory, and this is the actual size. Okay, point made. Got it. How do we use this avatar? Good question. Hi. So is your name Ishta? I don't know why my brain went to Ishtar. There is this app called ZEPETO, and you can use it on Android or, oh wow, that's rude. I'm not logged in though. You can use it on Avatar. What did I say? Any type of phone. It's just an app where you can create your own avatar. Some of them are 3D, some of them are not. Mine is technically not 3D, it's anime, but you can also have the 3D version. And yeah, it's free, but sometimes you have to watch ads to get money to buy clothes, or just do activities within the app. It's basically a game app, but I don't use it that way. I hope that that answers your question, at least partially. And if you want me to give you the name of the app, I will do that. There you go. Good. Yes. Despite it being 20 gigabytes large, we're able to load and access it with much less, you're welcome, RAM. So we can't really try it out, so I'm just gonna pass that. If you are familiar with pandas, sorta, this result might come as a surprise because of Wes Kenny's famous rule of thumb that you typically need 5 to 10 times as much RAM as the size of your dataset. So how does the HuggingFace dataset solve this memory management problem? Isn't it just streaming? I mean, I don't know, but let's see. The dataset treats each dataset as memory map file. I don't know what memory mapped would mean. Segment of virtual memory that has been has been assigned by a direct byte-for-byte correlation with some portion of a file or file-like resource It's typically a file that is physically present on the disk. Can also be a device. Shared. Memory, object, or other resources that an operating system can reference through a file descriptor. Once present, this correlation between the file and the memory space permits applications to treat the mapped portion as if it were primary memory. It makes it think it's saved on memory, but it's not? Is that no, not really. Interesting. Performance. I/O performance. Like paging or swapping virtual memory stuff makes it more seamless to use. Paging I get. So yeah. That is really cool. This provides a mapping between RAM and file system storage that allows the library to access and operate on elements of the data set without needing to fully load it into memory. Pretty cool. Memory mapped files can also be shared across multiple processes, which enables methods like dataset.map to be parallelized without needing to move or copy the dataset under the hood. These capabilities are all realized by the Apache Arrow memory format and PyArrow library, which make the data loading and processing lightning fast. There's a blog post that one can read to get more information about Apache Arrow. Okay. To see this in action, let's run a speed test by iterating over the elements. I mean, I can't do that, but we'll see your... Okay, in 1 minute. And we are... where are we doing time? Oh, there is time. Time it? Is that iteration with time? Are we doing it just for funsies? Oh, there's a code snippet. Wow. So you write the code snippet, you give it to the time it thing, and then run it once. That's pretty cool. I didn't know that existed. And then you print time, size. That's pretty cool. Here we've used Python's timeIt module to measure the execution time taken by the code snippet. You'll typically be able to iterate over a dataset at speed of a few tenths of a giga. That's byte, right? Per second to several gigabytes per second. This works great for the vast majority of applications, but sometimes you'll have to work with a dataset that is too large to even store in your laptop's hard drive. For example, if we try to download the file in its entirety, we'd need 825 gigabytes of free disk space. To handle these cases, the HuggingFace dataset provides a streaming feature that allows us to download and access elements on the fly without needing to download the whole dataset. Okay. Yeah, I know the time, but not the time it. That's also something. Streaming datasets. To enable dataset streaming, you just need to pass the streaming equals true argument to load the dataset function. For example, Do you know any other datasets like PubMed? I mean, I don't know datasets, but you can just look at the list of datasets that HuggingFace has, or probably just Google dataset lists. Like here, you can like say I want the dataset for text classification, and I want the dataset to be in a different language, for example, Arabic, and then you get a list of datasets that exist. For example, this is from Twitter. Yeah. So datasets can be found, but yeah. And if you want something that's like huge, I don't know if there is a, oh, there it is. We do have size. I guess these are not sizes of, let's choose like the biggest if it even exists, and press it. I mean, click it. Does it? Okay, there. Can you see right behind my huge head? It tells you size. You can size. Yeah, okay. It is one size. 26 gigabytes. What is this? And if I go to not, like, just remove the task so that we get more sizes. Remove this as well. We have like until 1 terabyte. And if I press any of them, Common Voices, obviously, that's pretty big. Common Voices is huge. Where can we see the size? It doesn't say, but it's a lot. I need to say about research papers. Oh, cool. Archive. Have you tried Archive one? I'm guessing there is something that has to do with Archive. Should I try looking for it? Reset you, and then reset you, and then let's just look. How is the word archive written? Is it like this? Yeah. See? ML archive papers, Python research code, math, physics, metadata, archive for classification. You can see title, abstract. Oh, that's all there is? Huh. That's pretty cool. Size is pretty small actually, but it has 100,000 rows, so it's not that small. I will send you this link just now and you can go further, all right? Good luck. Where were we? Streaming equals true. I think that's where we were. Double checking some things. You're welcome. Instead of the familiar data set that we've encountered elsewhere in this chapter, the object returned with streaming equals true is an iterable data set. So it's not CL streaming equals true. True. Currently, yeah. What was it? I heard the word, oh yeah. I got YouTube video recommended to me about streaming sites, you know, like streaming sites, Netflix, whatever. And in my brain, streaming equals Twitch, so I was like, you are ruining the word for me. And then now this is also ruining the word for me again. So as the name suggests, to access the elements of an iterable data set, we need to iterate over it. Yeah. Yes, Sherlock, thank you. We can access the first element of our streamed data set as followed. First element or next? Okay. So we can just call iter and next. So easily. Where are they from? Built-in function? Oh well. So using iter, if you say next, you'll get one. And you say next, you get another one, right? The elements from a streamed dataset can be processed on the fly using iterable dataset.map, which is useful during training if you need to tokenize the inputs. Will they be saved? The process is exactly the same as the one we used to tokenize our dataset in chapter 3, with only difference being corpus outputs are returned one by one, so it's still not saved. I like that. It's still an iterable dataset, basically like paging. Yeah. We do the same thing. Instead of having the tokenize function, we are adding it here. We're tokenizing the text part, and we didn't remove. Why is the input ID and attention mask? What about the other parts? Shouldn't it be text, metadata, and then input ID and attention mask and something else that I forgot? Or to speed up tokenization, you can pass batched equals true. As we saw in the last section, it will process the examples by batch by batch. The default batch size is 1,000 and can be updated. Got it. I do have a question, which is, where's padding? Because last time I forgot padding, and now when I see tokenization happening, I'm like, okay, what about padding? Where's padding? And you can also shuffle a streamed dataset using iterable dataset.shuffle. Wow. But unlike dataset.shuffle, this only shuffles the elements in a predefined buffer size. It does not shuffle everything. So you say shuffle me. Why is there an underscore here? All right. And then we say next and we get something else. Randomized study of dose or schedule modification. Cool. In this example, we select a random example. I don't like when words get repeated so closely. Okay? From the first 10,000 examples. Okay, now this was, I mean, I get it, why it's called an example, but like, you can just say in this section. In the buffer. Once an example is accessed, its spot in the buffer is filled with the next example in the corpus. Meaning the 10,000 first example in the case above. You can also select elements from a stream dataset using iterable.take and skip, which act in a way similar to select. For example, to select the first 5 examples, we can do the following. So you just take 5, put it in a variable, and then you can look at them. Cool. Basically like isn't it also the same take and skip in SQL? I think it is. Similarly, you can use the iterable.skip function to create training and validation splits from a shuffled dataset as follows. So you can say skip the first. Why? Oh, so the first 1000 is being taken here, and then skip the first 10,000. How big was the shuffled one? Okay, so meaning now you have 9,000 and you have 1,000. All right, fair. Let's round out our exploration of dataset streaming with a common application, combining multiple datasets together to create a single corpus. Ooh, that's cool. HuggingFace Datasets provides an interleave dataset function that converts a list of iterable dataset objects into a single iterable dataset, where the elements of the new dataset are obtained by alternating among the source example. This function is especially useful when you're trying to combine large datasets. So as an example, let's stream the free law subset of the file, which is 51 gigabytes of legal opinions from the US court. So load dataset, type is JSON. This is the link. We are taking the training split and we're streaming it. And then now we're just looking at one row. This is what it looks like. Case ID, case jurisdiction, date created, and the text. This dataset is large enough to stress the RAM of most laptops, yet you've been able to load and access it without breaking a sweat. Who's breaking a sweat? The laptop? Now let's combine the examples from free law and PubMed abstract datasets with a interleave dataset function. Something is happening to something. Let me try and fix it. Okay, fix it. Felix on the way. I think I fixed it. Okay, good job me. Oh, hi. Hey, Doppler. Sorry, didn't see you there because I was fixing something. What about 47? We had a huge discussion about the Doppler part of your name. Now we need to have another discussion about the 47. The question is mostly why. Hitman? What? I don't get it. I'm gonna Google this. Oh, fictional character, Agent 47. Of what? Is it like video game? Got it. Sorry, I didn't recognize it. Forgive me. Cool. Okay. Nice. I like how numbers become things that we recognize. Because like 42, Hitchhiker's Guide to the Galaxy. And now 47. What else? Also like numbers 7, 13 and all of that. 4 in Asian countries, 13 in other countries. I mean, like China, mostly. I don't know about Korea, but I know China is not happy with the number 4. So, interleaving the datasets. That's where we are. We have a new dataset that we just loaded. We had an already existing dataset. So we say interleave, and now we have something called a combined dataset. To iterate through them. Uh-oh. Whoops, where did CL go? What happened? Where is she? Somebody find her. She's back. Is there a different way of iterating through them? Isn't it just an iterable one? We say slice, I slice, okay. And we have 2 parts. This is part 1, this is part 2. We're using iSlice function from Python's iter tools module. To select the first 2 examples from the combined dataset. How is it first 2? Aren't they next to each other? Are they like merged? And we can see that they match the first examples from each of the 2 sources. Pretty cool. Finally, if you want to stream the pile in its entirety, you can grab all the prepared files as follows. So the pile is not one thing, it is a pile. Named good. That's good named. Base URL. What is this supposed to be? Training, validation, and text. This is crazy. There are 30? Why are we looping over 30? There are 30 databases? Wowee. Okay. Are they all named in a numbering way? No. Doesn't seem that way. Okay. We can try it with Oscar? I love Oscar. Use the large common crawl corpora like MC4 or Oscar to create a streaming multilingual dataset that represents spoken proportions of languages in a country of your choice. For example, the 4 national languages in Switzerland are German, French, Italian, and Romansh? Romanian? Is Romansh Romanian? No. It's their own language. Oh, okay. So cute. Okay, so you could try creating a Swiss corpus by sampling the Oscar subset according to their spoken proportions. You know what? We should actually try this. My level of laziness tells me at least try and learn something. Now we have all the tools needed to process datasets of all shapes and sizes. Unless you're exceptionally lucky, there will come a point in your NLP journey where you'll have to actually create a dataset to solve problem at hand. That's the topic of the next section. Oh my god, I want to create a dataset. Alright. So this is Oscar. Oscar is big. These are the sizes, 1 billion. And it is multilingual. That's a lot of languages. How do I unload them? And it's used for text generation, spell mask, so it's just text, internet text. So if I want to load it, do I load the whole thing or do I say filter by languages? Splits, there are splits. Oh, for each language. Huh? Deduplicate or... I don't get it. Hold up. if we want to use it, okay, see, that's what I wanted to see. You have to tell it what we want, as in the language. So that makes a lot of sense. So let's try that. At the end, let's add a section for Oscar. Oh, sorry. I don't think we have Muppets here, do we? Muppet. No Muppets. Nope. I can add a trash can. What? Would it be a bin? Hey. There is no emoji for a trash can or a bin? What else is there? You know what? Forget it. You don't deserve Oscar's trash can. So let's try getting... How many languages are there? I know, there are way too many available. So like AR is Arabic. Let's get one for Arabic. Let's get one for... I'm feeling Farsi. But would it be Persian? Oh, yeah. FA, got it. So we will have to load it twice. So this is AR, this is FA. But we're not gonna load it, we're gonna stream it. And for that, we would need the streaming equals true. Okay. I don't think I need anything else, like saying I need training or split. I mean, I could say split equals train, and then stream equals... What happened? True. Is it stream or streaming? Streaming. Sorry about that. Okay. That's it. Do I just load them? Uh-oh. Look at me forgetting to change it because I copied and pasted. I'm so good at that. Okay. Trust remote code. And then we can iterate over next iter. That's it, everything is loaded. So let's iterate over the first one, next, and then iter, data set AR, and see what we get. Something about graphic design and Dreamweaver. Oh. And then if we do the same for the Persian one, let's see if we can... Ooh. What is that? That's completely different. Gushi means cell phone. لباس پوشیدم و گوشی و headphone رو بردم. Oh, I can't understand everything, but I wore clothes, phone, and headphone. Someone's going somewhere. میگه ما وقتی خودمون. Those part I understood, but not this part. Said, what time, right? Yeah. Hey, هدية, meaning gift. Eba baqiya midam. I like Persian. But I'm too lazy to learn it. So now we get interleave and the slice. And we say like combined equals the interleave thing, and then we just, how do we call them? Brackets. And then we have data set AR. I thought the language was Farsi. Farsi and Persian are the same thing. Yes. Iran. Language spoken in Iran. Farsi is what we say. Persian is what English language says. And by we, I mean other, I don't know, like in Arabic and other languages, we call them the language Farsi. Understood. Yeah. Okay. What does the /n mean? Is this supposed to be an emoji? Because I know /s means sarcasm, but I don't know what /n means. Data. Oh my god, what is wrong with the caps lock and me? Data fa. Go. Line break. Why did the line break come here? Yeah. That's it. We just do this, and then list I slice. So we have our two first things. So after the combination, which, how long would it take? No, 0 time. We can say list, and then we can say I slice, and then look at the combined one. By the way, are you streaming tomorrow? I have no idea. I was thinking about it. Unknown. Answer unknown. Will this work? Yep. Dreamweaver, graphic design, and then the Gucci and headphone. Cool. Leap ha, saut ha, file ha. Leap? Like a music video? Oh. I don't know. I want to do like just a chill chat with Discord. I will ask if it's possible, if people want to join. If not, I may just do a different stream for funsies. Let's see. I don't expect people to be always available. We're here. We've used the, yep, we did that. Okay. And now we have a Persian and an Arabic. Iterable dataset combined. The end. Yeah, I read that. I did actually read that. So for the creating our own data set, yeah, as thought, as guessed, it's pretty long. So it's actually not that long, but it's long enough. That should be for later, meaning next time. Thinking I have 15 more minutes. Would that be enough to learn about this? Maybe not. Maybe. Probably not. Nope. Definitely not. Way too much. Oh well. That doesn't mean we'll give up. Let's go for 10 minutes of the lecture. It doesn't have to finish on a good thing, you know? Let's refresh and start again.
Okay, so positional encoding. So this is another really core part of the transformer model.
Mm-hmm.
And the positional encoding goes in here. It's added together with the input embedding. And because the transformer model is purely attentional, if embeddings only are used, there actually would be no way to distinguish between identical words. So because your
Really? Okay. So embeddings wouldn't know a big dog and a big cat would be identical. Why wouldn't it be identical? Does that mean a big dog is bigger than a big cat? I mean, yeah, but
Just taking the input embedding, if you had a big dog and a big cat, the attention values from every other place in the sentence would be guaranteed to be the same for big, right? So you would always have the same attention value for these words because their vectors are identical. And that's a problem, I guess, because like, as I said, sometimes syntactic,
Is the rain sound loud? I think it's alright. They're just saying the word big would be identical. I mean, but it is. It's normal to be identical. Let's see why it shouldn't be.
information needs to be pulled in from.
Because the way I see it, he thinks it shouldn't be. Meaning-wise, I can understand that a big dog size would be bigger than a big cat. But I don't know if that's where he's leading us.
Their vectors are identical. And that's a problem, I guess, because like, as I said, sometimes syntactic information needs to be pulled in from like locally coherent context. So that's a problem. A couple ways you can fix this. The first way you can fix this is use something that is sensitive to position, like an RNN. And an RNN, looks at which words came before, which words came after, and stuff like that. So that would solve your problem, but the whole point of transformers or attention is all you need is to not use RNNs. So we need another way to fix this problem. So the way this is fixed is using something called positional encodings. And so positional encodings add another embedding that's based on the word position. And so in addition to having something that's based on the word identity, you have another embedding that's based on the position. So
okay, so if we needed to recreate our sentence, no, that's not a problem though. I think it's more like both big is the same, but they want to be different for dog and cat. That's how I think he wants us to think, yeah. But like the position of where it is in the sentence should matter. And why? Because if we want to recreate the sentence, I can just say like the word big is, let's say 1, 2, 3, 4, 5, 2, 6, Like it's alright for it to be the same thing index-wise. But let's see why that's a problem.
Then the word big that appears in position 2 would be embedding of big plus embedding of position 2. And the word big that appears over here would be the embedding of big and then the embedding of position 8, for example. So that kind of solves that problem. There's a number of different ways to make these. The original transformer paper, they did it using something called sinusoidal encodings. This is kind of one of the, I don't know, when this paper came out and we were first reading it, when it first came out, it was like, they explained what they did and they explained very briefly why they did it, but it was kind of like a mystery, like nobody actually understood what they wrote in the.
So the big beside dog would be different when it's beside a cat. That's positional encoding. Also, hi Keen. I think yeah, it matters big dog versus big cat because your icon is a dog.
The paper. Luckily now there's a lot of nice blogs that actually explain this. And so the way these work essentially is you have a sign like this, and the sign is this weight times the time step in the output. And every even numbered embedding is uses a sign. Every odd numbered embedding uses the cosine. And this omega over here is 10,000 to the 2k divided by d.
And what is that?
So that's the value, and then this is the dimension size. And what these embeddings look like is something like this.
This is so pretty.
So if you, sorry, this is...
It reminds me of pictures we see on textbooks, school textbooks.
Very small, and also I should acknowledge that comes from this blog up here. But this is the position in the sentence, and then this is the embedding size, I believe. And so why did they choose to do it this way? They chose to do it this way because if you multiply these positional encodings together, you get something that looks a bit like this. And so if you multiply the two vectors together, you get something where if you're closer together in position space, you get a higher number. And so that kind of gives you a bias to upweighting the attention values of things that are closer together. At least right at the very beginning, like layers of the model where it's kind of more important because you don't have information calculated from the previous layers. So this is a basic idea. I think the thing on the right is the most important thing to know here, which is like this is the reason why they chose to do it that way. But that's the basic idea. Yeah.
Okay, I don't understand why this is so important, but apparently that's a really good thing. Is it something going down? This is just embeddings.
If it makes you multiply that faster, then I guess like why do we need to do this complicated not just something linear?
A student is asking a question,
Sorry, which part?
and we can't hear it, but we will in a bit.
In the reading,
Mm-hmm.
the position statement they talked about is it. If it's the word plus minus one, then you multiply it, let's say half and then a fourth and then eight.
Yeah, so I'm going to talk about that in a second, actually. Any other?
Oh, we didn't get it.
Okay, so this is what is done. Note that these are added right at the very beginning, and then you pass this through every layer. But basically, at the very beginning layer, at the very first layer, by using these positional encodings, you can kind of disambiguate. You can disambiguate this case here, and then after you passed it through the first layer, you're combining together information anyway, so you can have pulled in information about the local context, and now, like, it's essentially it's essentially already handled for you. Another thing is if you have residual connections, this gets passed into the following layers, which I'll talk about in a second. So,
Okay.
The second thing that you can do is learned encodings. And learned encodings, basically what they do is...
Sorry, just double checking that the stream is both on Twitch and... Oh, hi Ed, what's up? It's both on Twitch and YouTube, right? Not only on YouTube? Because somehow OBS is telling me it's only... No, looks both? Oh, okay, it's both. It was saying it's being streamed to one place, and that I found that to be odd. Yeah. I don't know why, but each time I see your character, Ed, it makes me think of Phineas Gage. Gage? I don't know. Cage, I think. It looks old-timey. Is it from like a video game character? Or is it an old-timey person? The filter makes it feel old-timey.
They create a learnable embedding that you just add in. And this is super simple. So it's like just like you learned the embedding for W big, you learned the embedding for W plus 2 or plus 6. And this is simpler. Like you don't need to think about sines and cosines and stuff like that.
I like
also
that.
more flexible because the model can learn anything it needs to, learn in order to do a good job of minimizing the loss. But the biggest disadvantage is it makes it impossible to extrapolate to longer sequences than you saw at training time. So because you have no learned embeddings for longer sequences, it's just it's
You put your
at
real
least in
name into
principle,
DALI and it generated that? That's smart. Ah, so your real name is Phineas Gage. Got it. By the way, I hope you don't feel, bothered. But let me see if I can find Phineas. I don't know how. Oh, there it is. Found it. It is Gage, not Cage. See, the picture feels like it, doesn't look like it. It's the guy that got rod into his brain and lived through it. I'm sure you've seen it on the internet. Being a person on the internet, we've probably seen it. He looks really cool though. Like, he lost an eye, but he looks cool. I mean, he looks cool anyways. Okay. And that was tangent. Let's see how further can we go. Okay.
possible to extrapolate to longer sequences unless you do some sort of heuristics. And if you do heuristics, you don't really know what's going to happen. So that's the disadvantage to doing it this way. In contrast, this, you just make k larger and calculate this deterministic function, and you could, theoretically extrapolate, but empirically models, even ones that use this sort of extrapolatable embedding, don't do super well at extrapolating to longer sequences.
I think I'll pause here. I think it's alright to pause here, even though it's a continuation of the thing before it, but yeah, I think I'll pause here and end the stream of an hour and a half. I'm not gonna, and wait, I am going to count the 10 minutes where I started the stream but wasn't here. So, if it's alright with you, I want you guys to help me plan tomorrow. My idea is to, like, whether it's a study group, whether it's a get together, whatever, on Discord, because I talk at people. I'd like to talk to people, with people, exchange ideas. There's a voice chat thing there. So if any of you would be interested, possibly available, let me know. Otherwise, I could do just another stream. But yeah, for some reason, I like my Tuesdays to be different. Like one day a week to be different. Yeah, so it would probably either be a Duolingo stream or something, or no stream, but just availability and being there on Discord to talk. So what do we think? Let me look at... By the way, you don't have to answer me right away. I'd know you in Discord if you set a time. I was thinking... I don't know what you mean by I know you. I was thinking creating an event. I think that would help, right? Voice chat event, and with a selected time. I didn't know such a thing existed, but apparently such a thing exists, and it can be done. But I don't know if everybody's available at the time that I would want. That's why. So yeah, I will set it. If like more than 2 people agree, then we can have it be an event. Let me try. Mm. Mm. Okay. Tell me when I say next if you can see it. Ah. Can you guys see it? Oh, okay, so you can say if you're interested or not. There we go. Events exist on Discord. That's pretty cool. Yes. It doesn't have to be informational, but it can be informational. Just trying to be active enough in the community, but not annoyingly active, because that's a balance I don't know if I can strike. Yeah. Cool. I think that's all for today. Yeah. I just put the link in the chat in case it takes a while for you to get there. And yeah. Oh, cool. I think people can see it now. Also, you actually don't have to talk if you don't feel like talking. That's also okay. You can just chat in the chat. Because I think people might get uncomfortable. All right. Thank you. I will say that I'm awake now. I was not awake an hour ago. I felt like a zombie. Let's do a quick review, and then I'll let you guys go. I think the leak. Uh-oh. Really? I don't think so. It says, invite link. Sorry. How would I test it? I don't think I can accept invite. I mean, I am me, but I will. Opening. You're right. You're right. It does go there directly. Not my fault. Twitch's fault. But yeah. I guess, yeah. Okay. So, we learned about streaming data that is very big. We took an example of 8. Well, it was like 15 gigabytes, but also the example was possible with more, like the 825. But we didn't do that. We did, though, try Common Crawl, which I think is pretty cool. And then, what did we learn in this lecture? Types of encoding, different types of encoding. Positional encoding, and then the something with sign encoding. And then learned encoding. And that's it. Even though it feels like we studied very a little, but it wasn't, because I tried doing the code. Oh, is that a better invite? Ah, thank you. The one that I put there was what Discord gave me. But yeah, thanks for the invite in the chat. Cool. I will copy and paste it so that it goes to both sides of the chat. And then, yeah, okay. So, I think that's all. Do let me know if anything else. You know, sometimes like at the end of meetings, you're like, oh, did I miss anything? Please let me know if I missed anything. That's how I feel like. It's like I'm ending a meeting. Please let me know if I missed anything. What did I miss? I don't know. Yeah. I hope you have a lovely rest of the day. It's Monday. Don't worry. It's cool. It's cool. Yeah. See you next time. See me next time. Maybe see you tomorrow if you got the time. That's all. I will end the stream in 5. Yeah. If you'd like to. Why did the character just die? Oh, there she is. If you'd like to stick around, please do that. If not, see you whenever possible. If not, see you never, I guess. I'm just saying you don't have to be here. That's all. Thank you, Keen. Yeah. Did I link the paper I mentioned about pose embeddings not mattering that much in... Sure. See ya next time, maybe Wednesday or so on. You can put it in the channel for the research things, and if wanted, we can talk about it. If it comes up, if not, we'll see. We'll see. Okay. 5, 4, 3, 2, and 1. That's it. Goodbye.